area of a triangle, page 7 of our using formulas notes. So triangles can be made out of a rectangle by cutting off some pieces, right? Let's talk about that. So right here I've got this triangle in blue, correct? If I draw a rectangle around it. White. Okay. So you can see that there's a triangle that I've cut out of a rectangle, right? So imagine you've got a rectangular paper, you cut off a corner here, you cut off a corner there, so that you have a triangle. So we're throwing pieces away, right? So does that mean our triangle is smaller in area than our rectangle or bigger? It has to be smaller because we're throwing pieces away, right? The interesting thing though is if you were to take this piece right here and flip it over, it would fit exactly with that part of the blue triangle over to the red line. And then if you were to take this piece right there, it would fit exactly in this side of the triangle because we really have just two other little triangles that if we put together, it makes exactly the same size as the blue triangle. Does that make sense? So we're not just throwing a random amount of stuff away to make our triangle. We're actually throwing away exactly one more triangle in the same area. I mean, it's two triangles, and it's two triangles that make the same area as the triangle we already have. So normally, to find the area of a rectangle, we do base times length times width, right? So think of it this way. Here's the length of our rectangle. Here's the height of our rectangle. I think I put a line across there. There's our rectangle. So length, width. Multiply together, we have the area of our rectangle. Here's the thing though. Our triangle is only half of that because we had a whole other triangle area of triangle pieces that we threw away. So instead of just doing length times width like we do with rectangles, we have a new formula, and it's 1/2 the length times width. Now, for triangles, we're not going to call it a length and a width because that doesn't make quite as much sense. We're going to call it base and height. The base can refer to any side of the triangle, and the height refers to the distance from the corner opposite perpendicular to that side. So let me throw away this rectangle for a second. So we understand that the rectangle would have an area here. I need to group it together so it doesn't not end up like I want it to be. That's still not quite like that. I'm just going to set that aside for a minute. Okay, so that rectangle has an area of here. Okay, length and width. So its area would be length times width. That's what we learned last time. But because we're doing the triangle, we only have half of that. And instead of calling it length and width, we're calling it base and height. And the height is perpendicular to the base. So notice on question 1, instead of it being drawn in as a height this direction from bottom to top, like what we normally think of as height, it's this direction, that little red line. But it's still perpendicular to this side here. So if you tilt your head or think about turning the whole triangle up so that this is across the bottom, then that would be the height straight up, right? So it doesn't really matter which way your triangle is turned or which side of your triangle you use as your base. The height will just be the one that's perpendicular to that base. So even though this is tilted, we can still use this as our base and use this part right here as our height. Okay, so let's go ahead and solve problem 1 by using our formula. So I'm going to take the base, which is 10, 8.5. You might notice I skipped the 1/2. Because I'm going to do the 1/2 a different way. Instead of thinking of it as multiplying by 2, or multiplying by 1/2 is what I meant, let's think of it more as dividing by 2. I think that's the easier thing to put in your calculator instead of worrying about that fraction. Dividing by 2 is the same thing as multiplying by 1/2. So that takes care of the 1/2, just dividing by 2. The formula looks like this, but when we actually work through it, we can write it like that and put it in our calculator like this. So 10 times 8.5 would be 85, correct? And then if we divide by 2, we get the area of this triangle. What's it going to be? Calculators out. Ready? Calculated 85 divided by 2, and we get 42.5. Awesome. 42.5. Don't forget your units. This is an area, so it's square units. So that would be 42.5 square feet. All right. Here's another triangle. There's the base, there's the height, there's the area. Uh-oh. We know the height. We don't know the base. We do know the area. We're working backwards here, right? Well, when we work backwards, problems like this, we do exactly the opposite of what we did going forwards. Going forward, we multiply the base and the height together, and then we divide it by 2. Let's go backwards. So the last thing we did was divide by 2. What do you think the first thing we should do is? What's the opposite of dividing by 2? How about multiplying by 2? So we're going to take 33, which is the area, and we're going to multiply that by 2. Because what that's going to give us is the area of the rectangle instead of the area of the triangle. It's the rectangle with the same dimensions. Therefore, it's an easier formula. Instead of having that 1/2 in there, we got rid of the 1/2 by multiplying by 2. Now it's just length times width, or base times height. So at this point, all we have to do to find the base, if we know the height, we take that 66 and we divide it by the height. So we're going to divide it by 6.4. And then that will give us the base. Kind of just like it was in the problems we did last time where we had the area and we had the length or the width and we had to find the height, which is divided, right? So the only extra thing you're doing with triangles is multiplying the area by 2 first to get rid of that 1/2. Okay, so what is 66 divided by 6.4? Give me an approximate answer here. Yeah, 10.3. Now there's other decimals after the 3, right? So technically that would just be like an approximate answer. If you ever want to tell someone that, hey, this answer is approximate, you can just use the little curly's equal sign instead. That just indicates, you know, this isn't quite exactly 10.3 because there were other decimals and I rounded it, but it's close. Now all of our units here are in inches. We have height of inches, base of inches, area of square inches. So we've got to make sure we remember that our unit measurement is in inches. Okay, so far so good. Let's read through some questions together now and do these. A triangular-shaped plot of land is 40 feet across the longest side, and the distance perpendicular to that side, then, across the property to the opposite corner is 70 feet. How much square footage is within the triangular property lines? When you're reading through problems like this, do you ever hear the Charlie Brown teachers? Wah, 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 like just kind of like turns into mush in your head reading through it? Yeah, I think that's pretty normal. So read through it once, embrace the mush, let it be. And then tackle it. We got this. A triangle. Let's start with that. So a triangle. Let's draw a triangle. That was easy. Draw a triangle. A triangular-shaped plot of land is 40 feet across the longest side. Well, I'm going to say that this side right here is the longest side, 40 feet. This is the hard part. The distance perpendicular to that side. So that side would be referring to this one. Perpendicular would mean that it's at a 90-degree angle, right? I don't know if you remember that word. to the opposite corner. Okay, so that's going to go up to the opposite corner. Oh, look, they were just describing the heights. It looked like a lot of words that I didn't understand, but when I just stopped to understand it, draw it out, I believe it's the height. Now that height of our triangle is 70 feet. Obviously, I didn't draw my picture to scale, because 70 would be longer than 40. Doesn't really matter though, right? It's still going to get the job. It doesn't matter if our picture is a little long. Okay, how much square footage is within the triangular property line? So this point is a formula. We're going to go area equals base times height, and then we're going to divide that by 2. Same thing as doing 1/2 base times height, right? So we're going to take the base, which is 40, the height, which is 70, and then I'm going to multiply those together and then divide by 2. Try that in your calculator for me. I'll give you a couple minutes. See what you get. All right, so 40 times 70 is, well, 4 times 7 is 28, right? So then if we have 2 zeros, throw those on. We divide by 2, and half of 28 is 14. So half of 2800 is 1400. And that is the area of our triangle in square footage. Get those numbers okay? All right, let's do one last problem together on this triangle here. Ask a question. It's triangle stuff. A triangle with an area of 793 square centimeters has a height of 37 centimeters. What is the width of the base in centimeters? So this is a lot like problem 2. It's just written in words instead of a picture, right? It's just got different numbers. So I'm going to draw a picture of a triangle with an area. So we'll say the area is 793 square centimeters. Has a height of 37 centimeters. So in here, the height is 37 centimeters. Okay, we want to find the length of, or the width of the base. So we are solving for the base, right? Well, let's take our formula. This time I'm going to do this a little bit more formally as an algebra problem using the formula. So my formula, remember, is area equals 1/2 base times height. So I'm going to plug in everything that I know. So I know the area is 793. The 1/2 is always going to be a 1/2 because the triangle is always half of the size of the rectangle. The base we don't know yet. And the height is 37. Notice how I left the units out for now while I do the math here. There's 2 different ways you can approach this problem. You could go ahead and do like I did in problem 2 and multiply by 2 to get rid of the 1/2. But another way you could do this problem is to actually do half of 37 first. Is that what you did? No? You're just thinking. You got the answer. Cool. Okay. So, since I did the previous problem by multiplying out that 2 and getting rid of that 1/2 first, I'm going to do this from the other way. I'm going to go ahead and do half of 37. So let's go ahead, let's do our 37 divided by 2 really fast. This is my little thought bubble. Half of 37 would be 37 divided by 2. What do we get? 37 divided by 2. Anybody? Let's see, 40 divided by 2 is 20. 38 divided by 2 would be 19. 36 would be 18. So I think it's 18.5. Really? Sigh. Yeah, we're almost done. So I halved the 37 instead of multiplying the area by 2. It's still going to work. So now, to find b, we're just going to divide both sides by that 18.5. So b is going to be 793 divided by 18.5, because we want to get the b by itself, so we're dividing by the coefficients. And we get the answer. Go to your calculator for me, tell me what you get, so I don't have this answer memorized. And we should get approximately, you can do a little approximate thing if you want to, 42.9 centimeters. I just rounded the 0.86